Hey guys, in this lesson we would understand the transformations of trigonometric functions and how to apply the transformations in order to turn the trigonometric function equation into a graph. Transformations of trigonometric functions are also explained in our sinusoidal functions playlist in the channel APS Education Math and Science videos. It is recommended to watch those videos before watching this video lesson because that is in more details, as that is a prerequisite for this lesson. The only difference between this lesson and the lesson explained in the sinusoidal functions playlist is that here we will be taking the angles in terms of pi's, whereas in the sinusoidal functions videos the angles are taken in degrees. Otherwise, all the steps would be applied in the same way in order to describe the transformations. Now we know the general transformed equation is y equal to a f kx minus d plus c. This is the general transformed equation for any function. If we have to specifically write on the general transformed equation for sine and cosine function, it would be y is equal to a sine kx minus d plus c and y is equal to a cos kx minus d plus c again. We already know from the previous knowledge or from the previous grades that a represents vertical stretch, vertical compression, and in trigonometric functions it also represents amplitude. Similarly, k represents horizontal stretch, horizontal compression, and in trigonometric functions it also gives us the time period. Similarly, d represents horizontal translation, and in trigonometric functions it gives us the phase shift. C represents vertical translation. In trigonometric function it gives us the equation of the axis of symmetry. Let's understand the transformations and turn the equation into a graph using an example. Let's say we are given an equation y is equal to 5 cosine minus 2x plus pi by 3 minus 2. We have to describe the transformations for this equation and also draw the graph of this equation. So the first thing we have to do is factor k out of the x and d bracket. So we would factor -2 out. We would be left with x minus pi over 6 minus 2. This is because when we divide pi by 3 with -2, we are left with minus pi by 6. Now we know a value is 5, k is -2, d is positive pi by 6, and c is -2. A is 5 means graph is vertically stretched by a factor of 5. K is -2 means the graph is horizontally stretched by a factor of 1 by 2 and reflected over y-axis. D is pi by 6 means the graph is going to show horizontal translation by pi by 6 units right, and C is -2 means the graph is going to show vertical translation by 2 units down. So these are the transformations described for this particular equation. If we want to turn this equation into a graph, then we have to go over certain steps which are as follows. So we're given the equation in factored form. Step number 1 is to plot C value, which is the equation of axis on the grid. So in this particular case, C is -2. If this is -2, then the equation of axes would be at -2, and that is this one. Step number 2 is add and subtract C and A to get max and min values on the graph. In this particular example, we have C is -2 and A is 5. When we add -2 and 5, we get a 3. When we subtract -2 and 5, we get a -7. When we do add and subtract, we always keep C first. The higher value is going to represent as the max value, and the lower value is going to represent the min value. Therefore, if we have 3 here and we have -7 here, so 3 would represent the max and the -7 value would represent the min value. Step number 3 is use k value to get time period. And the formula to get time period is t equal to 2 pi by k. In this particular example, because k value is -2, so time period will be 2 pi by -2, which is equal to -pi radians. Step number 4 is divide time period by 4. Our time period in this particular case is -pi. So we have to divide the time period by 4 and then write its 4 multiples to get the points on x-axis. because the time period is negative pi. So the first point when we divide the time period by 4 is going to be negative pi by 4. Second point is the second multiple of this. So 2 times negative pi by 4 is negative 2 pi by 4. Next point is negative 3 pi by 4. And next multiple is negative 4 pi by 4. We would use these 4 points to mark it on the x-axis. Because these are negative points, so we would make it on the left side of the x-axis. So the first point is negative pi by 4. Next point is negative 2 pi by 4. When we reduce it down to lowest terms, this would give us negative pi by 2. Next is negative 3 pi by 4. And next point is when we reduce it down, we would get a negative pi. So we always need to make sure that the fourth point should always be equal to the time period we got in step number 3. Now this is what we have obtained so far after completing step number 4. Step number 5 is use the parent function to draw the parent function graph on the grid without considering phase shift. Phase shift in our question is this pi by 6, right? So we would first use the parent function. In this particular case, the parent function is cosine x because this is the transformations introduced on the cosine function. So cosine x is equal to y is the parent function. Graph of cosine x looks like this. Whenever we make a graph of the parent sine or cosine function, we always mark 5 points. One is on the axis, so this is point number 1. Point number 2, point number 3, point number 4, and point number 5. So if it is a cosine function, the first point is a max point. Next we have is a 0 point. Next we have is a min point. Next is the 0 point again. And next is the max point. This is when the graph is with a positive. Because if the graph is a negative, so if it becomes negative cosine x, then the cosine function is going to flip like this. So the first point when a is negative would be min. The next point is 0 point. Next is max. Next is 0. And next is min. In our example, a is positive, so we would be using these points max, 0, min, 0, max. However, these points would be made on this grid. So the first point on the axis is the max point, then 0 point, then min point. 0 means on the equation of axes, min is going to be representing the minima point, that is -7, then 0 again, then max at +3. When we connect these points, we would be able to get this cosine function graph that has been drawn, taken care of a value, k value, and c value. However, d has yet not been used. Now step number 6 is use the phase shift to draw the final graph. In this example, phase shift is equal to d value, which is plus pi by 6. Pi by 6, if we write in degrees just to understand this better, is equal to 30 degrees. So we have to shift every point 30 degrees right. Now how do we find out how every point is going to be shifted 30 degrees right? Remember, pi by 4 is 45 degrees. So if we divide every part of the graph in 3 sections. So if this is 45, this is 15, this is 30 degrees. In the same way, we will divide the rest of the sections of the graph also in 3 parts. And now every point is going to be shifted 30 degrees right. So this section represents 15 degrees and this section represents 30 degrees. Every point is going to be shifted pi by 6 radians or 30 degrees right. So this max point will come here, this 0 point will come here, this min point will come here, 0 point comes here, and in the same way, if we divide 3 sections on the right side, this max point would come here. Now we just have to connect these dots and we would be able to get the final graph. So this final graph is the white graph that represents this function that is drawn after taking care of each and every transformations involved in this cosine function graph. Let's quickly summarize the steps. The first step is to plot C. Next is we find out the max and the min points by adding C and A and then subtracting C and A. The bigger value will give us the max and the smaller value will give us the min. Next step is to find out the time period using k value. Here, because k was negative, that's why the time period is negative as well. Then the next step is to divide the time period by 4 and then write down the multiples of that value 4 times to mark the points on the x-axis. So when we divide time period by 4, that is negative pi by 4. That gives us the first point. Next is the second point, third point, and fourth point. These are the multiples of the first point. Next step is to use the parent function to draw the parent function graph on the grid without considering phase shift. Because this parent function was cosine, so we would be drawing the points using cosine graph. This is how we draw the cosine graph points if a is positive, and this is how we graph the cosine points if a is negative. Because our a was positive, so we would make max point first, then 0, then min, then 0, then max. And once we make this graph on the given grid, that is this one, then we use the phase shift to move the points according to the phase shift to draw the final graph of the given function. And this is how we use transformations to draw the graph of transformed trigonometric functions.